Okay, well, let's make a start. Hopefully you can see that. But I think what I'd like to do is just talk about kit building. And the reason I kind of thought we would do this was really for two reasons. One, that other people I've kind of interacted with in terms of building kits over the last year or two have said to me, well, how do you get your kit that kind of works first time? And we've had all sorts of problems. And I kind of said, well, I guess I've had so many kits that haven't worked, I've kind of learned what makes a kit work. And they then said, well, can you come and talk to us? So I thought about actually putting a talk together for them. And I thought, well, given that we've got the club project, which is a club construction project, which is a kit, it's probably appropriate that I perhaps do some of that talk now in terms of just some of the things I've learned about kit building and hints and tricks really on that. So this is kind of my take on it, really. Your experience may be completely different, but this is my take about melting some solder and making some kits. Next slide, please. Let's just get the next slide up. So why do I like kits? Well, I kind of like kits because you get all the bits. You don't have to sort of worry about all these deliveries from, eBay or AliExpress or whatever to get all the bits and pieces. They're all there for you. And actually, sometimes you get the case as well. And you tend to get a board, a PC board, and I'll come back to the quality of those a bit later. But you tend to get all the bits, which is handy, and I think I quite like that. The other thing is that you tend to get something that actually has got some pedigree for actually working, and on the construction of it, you usually get the circuit diagram, and it's kind of informative about looking at the circuit, making the thing, and you actually kind of learn from the actual circuit how it functions and how it's put together. And I found that really educational over the years. I've also found largely that people that take kit building seriously and supply kits seriously tend to be helpful. And so even the Chinese kits in time, you sometimes have to wait for them to come back. And you sometimes have to go and find a Chinese student that actually speaks English and Chinese to actually work out what they've said or what the guidance is. Or sometimes actually Google Translate is fine to try and get help about aspects of the kit. And it's not uncommon with a lot of the Chinese kits that some of it is not very obvious really in terms of putting it together, but there is some help there. And I think with experience, they do tend to work first time. And that's kind of recently. I've never really had a kind of kit failure over the last 3 or 4 years as I kind of put more of these things together. But there's really two sources of kit to consider, and you just have to take a different mindset really for the kit. So there's the kind of innovator kit companies, and there are lots of them, in the UK, in the US, one sourced from Turkey, one sourced from India, and they've really, carefully put that kit together and supplied it so that you should have a good chance of actually getting it to work first time. And there are groups supporting them, and they tend to have IO groups and all sorts of stuff. So over the years, I've kind of put a lot of those kits together and had quite good interaction, not only for getting the kit working sometimes if you've missed something, but also that you've kind of recognized that some people have taken those kits forward and actually made them even better by actually doing amendments to them in terms of the circuit or in terms of adaptions. And then the other source of kits, which I'll come on to, are the Chinese clones or the Chinese copies. And sometimes actually they're copies of copies. And the quality can be very variable. Sometimes it actually can be quite good, but sometimes it can be actually appalling. And I'll come on to some of those a bit later on. And if you get a case, it tends to look fairly professional. It makes a nice piece of shack kit, really. So what are the initial considerations? And I think it's what you want out of it and what you're prepared to perhaps invest your time in and pay for, really. So, again, it's dependent on whether you're going to go down the innovator type kit route or the Chinese kit route. I don't know if any of you have ever made the Elecraft K2, but that is a big project. I mean, that took me a long time to make, and it worked first time, and there was a huge amount of support. and it's probably, I think, the best kit that's ever been out there in terms of making a K2 on that. And I made it for somebody else, and I got the joy of making it, and he gets the joy of using it. But it was new, and I think they still sell it. I think the other thing is that you have to decide whether you can do hole through, and most of us can do that, or whether you can go for surface mounted. And I do a limited amount of surface mount, and I guess as I get more experienced, I can do a bit more. And you just have to be careful sometimes that hole through, and you can see an example there where it's not great on terms of hole, but the holes are plated, and that creates some issues sometimes about whether you can actually make it easily or not, and cope with it, particularly if you want to change or unsolder things with plated holes. So, look out for that. I think plated holes are best, but you just need to recognize sometimes that if you've got plated holes, they're more difficult to change components. And, there are levels of competency. I show you something at the end that's a very, very dense board. But actually, if you're slow and steady, you've got every chance of making it work first time, really. But it's about stretching yourself and trying things and understanding things that you didn't quite understand before. And many of the things that I've made with things like Arduinos in, I've kind of had to kind of learn as I went along, particularly about the software part of the Arduino to make it do what I really wanted it to do. And some of these kits sometimes are quite useful models for making, or modules for making bigger things. So, you can get 3 or 4 modules working, from kits, and then put them together to make something bigger. But it can make a nice piece of shack kit. And what I think there are some basics to go through, and all of you will do your own thing in terms of how you do this, but just a word about solder and soldering and unsoldering and keeping clean and tidy, and what construction aids there. But you can see the best construction aid I've got is not something with crocodile clips on, but that board holder that you can flip upside down, and you can lock it at an angle, and I find that the best thing I've got for that. But also sometimes if it wobbles, you can see I've got a little plastic clip there that I can clip things into. I'll come back to all that a little later on. So, before you do that, just think about these things. You may not want all of these things, but they're handy to have. So a solder station is kind of handy because you can change the temperature. And if you can change the temperature and you can keep the end of the iron hot, that really helps with some of the small soldering stuff and big soldering stuff that you wanted to do. If you've got a lot of relays on and you've made boards with relays in and you've got to desolder them, the only way of doing that really is to have a desoldering tool that you can heat it. And, I've got a Hacko one, a fancy one, but you can get one relatively inexpensive to desolder, and it sucks the solder out once it's hot. And it means that you can reuse the relay, and usually you can reuse the board. Having a multimeter to do all sorts of things is handy. And I use a component analyzer. So every component that I put into a board, I check before I put it in. And again, that's just part of what I've learned, that it's worth the effort to do that, because it saves the tears at the end, really, on that. And I'll come back to some of those points a bit later. The thing that's useful to have on occasions, particularly if you hit a problem, is an RF sniffer and an oscilloscope. I kind of only use mine perhaps once a month, and the RF sniffer probably less so, but they're handy to have. And also these days you can have a nano spectrum analyzer, so you can look at outputs of things. And I found that for the first time, I actually had access to those and found that very useful. For 40 or 50 quid, you had something that was really very useful for that. So these are useful things to have if you're beginning to look at if you've got issues with a kit, getting it working, or issues in terms of signal tracing. I think the other thing is, in a club like ours, you've got a lot of very able, technically very able people there to help. So, many things that you don't understand and many things you learn on the way, but actually there are a lot of people that kind of know the answer. So it's a question of using the club and all the people in the club to kind of help you on occasions. And hopefully, we've got an environment and a culture happy to do that. And I guess the things that make it easier is just having patience, that sometimes, slow, steady, and thinking about what you're doing is probably one of the keenest assets that you can have in terms of making kits work first time. So kind of what I do really is when I start the kit and the things I learned the hard way, I kind of lay it all out, and you need bag discipline. Most of the kits, anything that's substantial, you get lots of bags of bits. And sometimes the bits have got some logical order. Sometimes they haven't got logical order, but you just have to have discipline to not open the bags that you don't need and get those laid out. And then what I do, I don't know whether it used to be an old Heathkit trick that the cardboard box that the Heathkit came in, you cut it off, and the kind of corrugated holes that you get along the way, you put the components in the order that you're going to load them onto the board. And okay, I may be a bit anal, but I still do that, okay? Except I use a piece of that not rubber, but foamy stuff, black foamy stuff, and lay them out in order. So I can pull them off, check them, and put them in the right place. I just found that that's a very ordered way of doing it, and it helps the discipline of making sure you get the right component in the right hole. The reality is that yes, you can correct it, but getting them out sometimes is a pig, and actually working out what their values are when their values are hidden by the component that's next to it is not necessarily easy. So getting it right first time is probably an important part of it. And actually, for some kits, small ones I don't bother, but for some kits, I kind of mark on the circuit diagram as I go what I'm building and what component is going in, and I mark it off on the bill of materials and the component list. It depends. On the K2 that I built, I did that all the time. It was just a huge kit, and it was, it had to work because it wasn't mine. So I spent a lot of time marking off as I went. And some of the kits, I still do that. Depends on the complexity. The other thing is that although we all know how to solder, like all things in life, there's a knack, and you can actually develop your knack. And I found if I count sometimes 2-2-2, anybody use that at all? 2-2-2. So it's 2 seconds to heat, 2 seconds solder on, and 2 seconds to keep it on once you've taken the solder off. And I sometimes do 3-3-3 depending on the size of the component. So I count that in my head, and it's a way of making sure that the solder is fluid enough to make the joint, but not overheating it. We'll come back to solder in a minute, but not overheating it, so that you actually solder is eutectics. If you remember your chemistry, the eutectic has got a lower melting point than 2 individual components. But what happens is you overheat it, is you begin to change the dynamics of that mixture, and therefore you change the melting point. So you need to get it at the right point with the right melting point to make it work. And frequently that means not overheating it, but making sure you've got a really hot iron to go in the first place, really, on that heats stuff up. I mentioned about plated boards, double-sided plated boards. They're fine, but remember that sometimes if you've soldered into the plate that actually goes through the board on the component, that can be a pig to get the solder out. That there's a technique which I'll come to, which I find useful for that. But I also make mistakes on the times, and I have to take them out. And a double-sided board can be more difficult because it's a plated board, and keeping track of what you've got upside, top side versus bottom side can be difficult too. But so errors are difficult to correct once soldered. So the important thing is don't solder them in the first place, but that's easy to say. And the other thing which I have done is that I have put kits together, forgot to put a dummy load on and put it into transmit, and it tends to do things like generate white smoke. So don't forget the dummy load on the end, particularly when you're sort of, you're taking up a PA or a linear amplifier or whatever. And I've done that on occasions too, which is, I've corrected it, but it's been hard work. So just talk about soldering. I use this is my Hacko, and the reason I like it is that I can control the temperature. And So what I normally do is I for the printed circuit board, particularly if it's double-sided also, I use the nylon scratch pad to clean it, and fingerprints and all that sort of stuff. But sometimes they've been in bags or they've come from China or whatever, and they're not that clean and they've got gunge on and stuff. So clean it. I think the other thing is don't be afraid to use flux. I use, like we all use, flux-based solder, but actually you need extra flux on occasions, and I use that liquid stuff that I showed you that is a no clean flux, and it's not as good as the sticky resiny stuff, I don't think, but actually it's enough sometimes just to make a difference. And the sort of solder I like using, and I'm sorry, I haven't gone across to lead-free solder. I've tried it and tried it and tried it, and I just think it's rubbish, really. And I'm sure professionally people can get it to work and work well, but I can't. So I like the 6337 lead solder. And at one time, and I haven't seen it for a bit, and I think I'm coming to the end of my stock at home, actually, you could buy it with 1% silver, and that is a beautiful solder to solder with. And it's just got the right amount of time in its fluid state to make a good joint. I talked about unsoldering from plated holes if you made a mistake, and I used to, heat the joint and cut the component off generally, but heat the joint and then poke it through with a cocktail stick. So you want something that the solder doesn't stick to whilst you've got it hot, so you can poke it through the hole. I built a kit, and there was a kind of hints and kinks stuff that the guy sent me, and he said he used a quilting pin. Now I'll show you the quilting pin a bit later on. I think no, the quilting pin is those pins there. Sorry, you can't see them. Sorry, Francis. Can we go back? Yep. Okay, so the quilting pins to the right-hand side there, those little things with orange blobs on. And you can buy 1,000 for about £4 or something on Amazon. And the solder doesn't stick to them. They're kind of stainless, and the solder doesn't stick to them. So you can poke them through and also not get your hands burnt. But they also don't bend like the cocktail stick. And they're a good way of actually re-cleaning the hole. I'll come back to that. So let's go back to that slide, if we could. I use that and a bit of solder wick to clean it up. And on occasion, sometimes I have this kind of mini drill thing, like and I have actually, as well as cleaning it up, just to make sure it's really clean and like it was to start with, I actually run a very fine drill down it, just to sort of drill out any spurs or bits and pieces of stuff to put in there. But for big components, like relays sometimes, or big inductors or stuff, you do need a gun. And I haven't got a picture of it here, but you can get heated vacuum guns, with bulbs and things on them for a few pounds, and they kind of work okay. And if you do a lot of unsoldering, which I did at one time, I did buy an electric one of those. When I'm doing a board, I kind of do the board, and it's usually marked top and bottom. And if it's plated holes, I actually put the component through, and if I can, I keep it so that the component is tight to the board, and I solder from the top. Now you can't always do that because of the component doesn't let you do it, but there's no space. But solder from the top first, and then I flip the board and solder from the bottom. But obviously, do it from one side to one side, so it's in it, and it's a way of making sure that you've got a good firm joint and also good electrical joint for that too. So that's kind of what I do on that. I do play around with surface mount stuff, and I've built surface mount stuff, and I probably don't do it very professionally, but I do it with a hot air gun, and I don't have an oven or whatever. But I found that there's a limit to what you can do, and I found that 0805s, if it needs anything less than smaller than 0805, I kind of pass on it really at the moment. I've played around with the stuff that's small, and it's just hopeless. I just can't do it really on that. But for the right iron, you can do a lot of things, and I use tips. Actually, I've got 3 irons that plug into that DIN plug. So I've got 3 tips. So I've got the pointed tip, the small chisel tip, and the big chisel tip. And I just plug those in depending on what components I'm putting in. And I tend to keep it pretty hot, 222 not 2022. So just for 222 to try and get that board made. And I use one of those PCB holders. I don't always do it, but depending on what I'm doing, you know, I put the electrostatic band on and whatever, and you know, make sure that's earthed. You know, getting a reasonably expensive soldering iron means that the soldering iron is earthed as well, and it just helps with the stuff that could get zapped on that. And then, well, I've bought them at Friedrichshafen, but you know, if you get, you know, medical tools, then or dental tools, that you can find all sorts of reverse tweezers and reverse clamps and all sorts of stuff and prizing that you can actually really useful for doing all this sort of stuff. So I've got 2 or 3 sizes of reverse tweezers that holds components in whilst you solder them, and sometimes that's you know, that's useful too. So I don't think I showed you on the bench there, but I do have a box of tweezers and all sorts of stuff to nurture some components in from time to time. And the other thing is just useful to have is, and I just use an old computer fan, is that I've got no desire to breathe all this hot flux fumes and stuff and sort of lead vapor. So I blow the stuff across the board as well, but try and make sure it doesn't actually cool down any of the soldering that you want to do. So it's just taking the fumes away. I'm sure it takes it to the other side of the room and it all comes back again. But anyway, it makes me feel better on that. Next one. So, you know, what's you know, what do you do to protect your hard work? Well, I don't do this religiously every time, but if it's logical to do it, and I tend to do it with particularly power supply components first, or power sections, is test the section if you can, and making sure the voltages look right. I'm kind of a great believer in making sure that you know, you get sample voltages from the kit manufacturers to make sure that you're on the right path sometimes, or you could identify either the component or the section of the kit that doesn't match up. And generally speaking, the biggest problems are you've soldered it wrong, or you've put the wrong components in the wrong places. It's been down to me. So, and you know, there are reasons for that sometimes. So I've kind of learned that don't do it when you're really tired, because you're bound to make a mistake. So if your concentration's beginning to go, stop doing it and start again tomorrow. Perhaps I've got the luxury of doing that. The big Achilles heel, other than dry joints, then is really insulators and toroids, and as you know, what you've got is wire, and it's actually been enameled, and you don't get electrical connections very well unless you take off the enamel. So the insulation is you know, it's better than it was years ago, but they say you can burn it off. Don't believe it. You know, it's better than it was, and the really thin stuff you can probably burn off, but the stuff that's thicker, you have to remove it. So I use an emery board. I'm sorry to go back to the first one, but you can buy 1,000 emery boards for £4 or something on Amazon. And I use an emery board and cut them in half, and then just scrape the wire down the emery board, and then throw the emery board at the end. And it's a way of actually taking the lacquer off. And then tinning it, and that generally is the biggest problem. The problems I had, the MCARS 80 that I made, you know, when I lived elsewhere and bought the kit and stuff. The problem I had was the toroids on it. I couldn't get that lacquer off and get good and I learned that and good soldered joints. So that's the biggest Achilles heel, I think, really. And if you spend time getting those toroids right, generally the kit will work, I think, really. There's, you know, wind the right number of turns. It seems obvious, really, and I kind of don't always do that. I kind of like putting an extra turn on and then taking it off if it needs it, partly because actually the toroids tend to be very variable. You know, the tolerances aren't brilliant, and they're not always great, particularly if you buy them from perhaps, you know, sort of Chinese sources or whatever. So I tend to kind of take turns off at the end sometimes and put extra turns on in the beginning, because you can't do it the other way around. And particularly when I'm building things like bandpass filters or low pass filters at the end of PAs, I like to have an extra turn on there I can take off rather than, that's my choice. But I do check, you know, with the VNA, I've got a inductance meter, and I do check with the inductance to make sure it's in the right ballpark on that. The other thing is that the damn toroids are easy to mix up. So you get toroids in a plastic bag, and then you open the plastic bag, and then, you know, they're not all the same. And sometimes, particularly from some of the other kits, you know, what you get in one kit, they're black, and another kit, they're red, but they're the same thing. And so sometimes you can't rely on a black one's usually this and a red one's usually that. So I kind of a little anal, I suppose, really, with the toroids to make sure that I've got them really well identified. So I don't put them on until the right point. And then I do go over what I've done that day with, and this sounds all very anal, but I'm just making sure that the kit works first time, is to inspect all the joints. And I use a jeweler's loop, but obviously when I do SMD, I've got one of these little 3D microscopes, which are relatively inexpensive. I got that from Banggood or AliExpress, and I found that pretty good for looking at stuff and inspecting it at the end of the day, and then I'm ready for the next day. And like all these things in life, really, if you follow the instructions, you know, decent kits have people that have built them before, and they're pretty good instructions really on that. So, you know, the K2 instructions and Heathkit instructions, and actually QRP Labs instructions are really excellent. So a couple of words on these cheap Chinese kits. This is one of the kits, they call this the 49er, and it's actually a copy, or it's actually a copy of a copy of something that was in the States. And I've made quite a number of these for a number of reasons, because I've used these as modules for transceivers and stuff on occasions. But component quality can be really doubtful. So this is really where testing every component. So I found, you know, I've received transistors that don't work. I've found components that have not been labeled, and you've got to work out, you know, whether that, you know, what the value is. Sometimes, you know, the component is, you touch it and the actual numbers come off the actual component, and you realize probably it was a duff component that, or didn't meet spec, that's been relabeled at some point. So I'm never sure they're the right pedigree of components. But, you know, bearing all that in mind, you can actually test these things really. I found in these kits sometimes that, you know, components are missing. So it's always handy to have a few general bits and pieces in, but they'd be missing. Or sometimes you get 10 of something and you only need one, and you get a handful of these things, and you think, oh God, what am I supposed to do with the rest of it? I must have missed something somewhere. But you haven't. It's just the way that they put these things together. But I guess what can you expect for a few quid, really, which is what these things are. So actually, what I sometimes do is, depending on the source, I sometimes, because they're relatively expensive, I might order 2 or 3 of these things, in case I need another component, or in case I can refer across to the other bag that what that component was, that, you know, where the printing has rubbed off. And it again, it's getting something that actually you can make sure it works. But they are inexpensive. You can do that. Again, you know, the Chinese instructions sometimes are, you know, there's a paucity of information really. But you know, with Google Translate and Chinese stuff that comes through, I've managed through. I found actually that the PA transistors tend to be the ones that, well, they're the ones that are most circumspect, most circumspect. So I found that if I have a little stock of them, then if I test one and it doesn't work, or test one and it, you know, it looks odd, I can get one out the store and put one in and make it work. So be careful with the Chinese stuff. And this board here, these are some of the issues, you know, in terms of adapting it. I took off the crystal controlled oscillator and put an input to a VFO there, and took off the crystal filter. And, you know, for £3 to £8, it makes a decent little 40 meter transceiver with a couple of watts. And I've worked all over the place on the thing. I'm not going to show it now because it was not enough time, but use that as the basis of a module for a transceiver. But I always made that work first before I did the adaptation. Next one. And this is an example, really. So on the right-hand side is the Chinese board. You can't really see it very well, but you can see it's a different color. But I found another guy in Hong Kong that had copied it, but actually he copied it better. So actually his circuit board was about 10 times better than the one I could get from China. And I found it was just easier to work with. So I started to splash out and buy the really expensive board from Hong Kong, which is what the basis of putting the 40-meter transceiver together on that. So just a couple of examples about the board. And these are a couple of this is my kind of Chinese stable. I've got kind of more of these now, but I've made the 49er and I've made one called the Frog, which I wouldn't recommend. It's not great. And there's one called the RM80, and it all depends. This is the Rock Mite. So you may have seen this in America. It's the Rock Mite. And that kit was really good from China, very, very good. Needed a bit more audio out. So you can see I put a little adaptation board there to give you a bit more audio out. But that was really nice. And what let it down was that the guy in China had copied a CW keyer in it, and he hadn't copied it very well. So it's awful. So it's okay if you actually send it, but the CW keyer, if you use it and it's got a memory and stuff, it's just awful. So there is actually a fix. I found a fix on the internet for how you can go and do that, but I've never bothered, and I've used that. So there's a couple of kits there. And these are a couple of more sophisticated kits, I suppose. On the left-hand side, I quite like the QRP Labs kits. I think that's a 40-meter QCX transceiver, their CW transceiver. That was a nice build. And then there's a little linear amplifier he sells that takes it up to 50 watts. So CW only, but you can use it for digital. And in fact, I've been using that for the new MCARS transceiver on that. And on the right hand side, there's a board I got from India that I've adapted and all sorts of stuff, kind of learn on the way to make that better than it was. But the bones of it, came out of a kit from India, where in fact they did a lot of the initial board for you. And I mentioned that 50-watt amplifier, and that's the innards of it, really. And that got me going for about 18 months building linear amplifiers and keep building bigger ones and stuff. But it was quite educational to put that together on that. So coming to the MCARS one, which is the one that's going around at the moment. On the right-hand side there, you can see a finished unit, which is one of Steve's finished units, and that was a 20-meter one that I built, and it runs quite nicely. The middle picture is the picture with the board, so you can see that the main board is there, and you can see the kind of CW filter board is the one that actually plugs into it. So that's a second board there. And yeah, it's a pretty dense board, and there's a lot of components, and it doesn't test your eyesight. You just have to go slow and steady, and you can put that together. And I found that relatively straightforward to put together. On the left-hand side was one of Steve's earlier prototypes, and I got that just in it was just basically a board, and I put it into a little box. But that was a 40-meter one. But I've had contacts on those, sideband and CW contacts on those, and it makes a really nice little transceiver project. And there's help around in the club, should you do this, to help you get it going and get it working if needs be. And there's just a couple of other pictures of the board, the board finished and ready to mount in the case. Just a word, and again, it's just how you do these things. But Steve has left components that you need for different bands, and then you build the 40-meter part of the kit or the 20-meter part of the kit, and you don't fill in the components for one, versus the other. So what I do is sit down and actually blank those out with a felt tip first, so I can't put the component in the wrong band position. And again, that may be very anal, but it's a way of making sure that you get a kit that's actually put together properly. So there's a couple of examples of that. So don't be bashful. It's a kit that goes together relatively straightforwardly, but it just needs to be taken steady on that. And Steve's put a nice case together to put the thing in. So concluding remarks really is that, if you're getting into this for the first time, try some simple kits. I'm not sure I'd start with the Chinese kits because they can be fiddly to get going sometimes. But there are some simple kits, and there are kits like crystal oscillators or battery monitors, all that sort of stuff that you can put together. The other thing is that, try something that's going to stretch you a bit and you'll learn from, and you kind of look at kits and think, can I really build that? I'm not sure I'm up to that. But actually, if you spend enough time doing it and doing the right research and reading, yeah, you can do it. And it's because people have done it before, and that you can get help on occasions. You'll decide how much test and construction equipment you really want to do this, but there's so much that's relatively inexpensive now that even I never dreamt I would have a spectrum analyzer, but the little nano spectrum analyzer is kind of remarkable. Coupled to a laptop is quite remarkable for the money. To actually build a real quality kit like that, it's available. NCARS has got its transceiver kit available, and now's the time to melt some solder. So have a go. So that's really it. I mean, I don't think on this version, but I've got all sorts of pictures and stuff. But have a go, and it's not as perhaps formidable as you imagined. So I'm happy to take any questions. That's my take on it, really. I guess I've been fortunate that over the last few years kits have worked first time, but for a long time they didn't on that.
When you were talking about cleaning up the board
to
start with, is it the case that the sort of plating around the holes would oxidize if it stood around for a while? A
little bit, yeah. So what I normally do is kind of zap it with a bit of IPA. So I've got a bottle of isopropyl alcohol or rubbing alcohol, spray that, and then gently. Some of the Chinese boards have got so little copper on that it's very easy to wear it off. So just do it gently. But some of the decent boards have got decent amounts of copper on. But so I just gently take it off with one of those nylon sort of pads just to clean it up and take the oxidizer.
Another thing, I would be very careful drilling up, because if you have a multi-layer board, the barrel will be interconnection for the internal layers.
Yeah.
So if you drill it there, you break the connection to the internal layers. So I would be very careful with that.
Yeah. So that's kind of last resort if I have to do that. But I tend to do two-sided boards only, so you can see both sides really on that.
Phil, you mentioned 222 when you're soldering. Sorry, what did the third 2 refer to? I didn't quite get that.
Okay, so Andrew, it's 2 seconds to heat the joint. So put the soldering iron on the joint, 2 seconds solder being flowed into it, and then 2 seconds where the solder's taken away and the joint's making it good. It's flowing into the hole and everything.
Okay. I get
it,
yeah.
And getting to the point that this solder doesn't change color or granularity so that you've lost the eutectic, really, and the characteristics. It's a way of avoiding dry joints. The guy that kind of at the last club I was at, I mean, he did a job professionally. He used to put a little bit of resin solder on the end of the, so he had a resistor poking through in the joint there. I don't know if you can see, you probably can't see that there. So he'd put a blob of flux just on the end. So as you heated it for the first 2 seconds, the flux went down into the joint. And he said that was kind of military soldering. I don't know whether that's true or not, but I do think about that sometimes. If I've got something that looks as if it might need a bit of extra flux, I do put some of the resiny flux just at the end and let it flow down into the joint.
Great, thanks.
Okay.
I've got a question, Phil.
Yeah.
As you know, I'm interested in Morse, and I've got a Morse keyer kit which dates back to the 1970s. It's a CMOS keyer, and it's a double-sided printed circuit board. Now, I could make it up, but if it all goes wrong, I can't start again. So my question really is there a simple way of replicating a double-sided printed circuit board so I can use the unused board as a guide, and then if it all goes wrong, I can start again because I can get a new board made from China?
Well, the answer is I honestly don't know, but see, what you want to do is take an image of a board you've got and then getting another one of it made. Is that what you're asking, John?
Yeah, that's what I'm wondering. I'm just wondering if there's an easy way of doing it.
Well, you can make circuit boards, with laser, laser printer and stuff, and then so I don't know whether you can take a photocopy with a laser printer and then use that to make the board, or whether there's somebody who can do a kind of a photo, take a photo or an image of it and convert that to a board. Les is.
Way of doing that. The only thing you could do is if it's a single layer board, you literally redraw it.
Yeah.
But if it's a 2-layer board, it's already complicated.
It is, yeah.
I was wondering. I can. The reverberation makes it difficult to hear what you're saying, Les, but I can sort of understand that redrawing a double-sided board is going to be quite challenging. So I just wondered if there was a simple bit of tech which replicated a double-sided.
I mean, you can go into, there's quite a lot of home brewing kind of Facebook groups. And you could, there may be somebody that knows how to do it or what to do, but it's to ask the question there, really. I can let you have details of a couple of them. There's an American one and quite a good British one.
I just feel if I use the board and make a mistake or some of the copper comes off, I can't easily start again. Whereas if I could replicate and have a new board,
have you got the circuit diagram? And
oh yes, yeah.
I mean, generally speaking, although it sounds dramatic, you can repair the boards, with fine wire and stuff. Generally, one occasion I couldn't, but most of the time you can repair boards. Sometimes you heat them so much, and then the copper delaminates. But you kind of learn not to do that after a bit.
I've still got a very much repaired ZX Spectrum.
There you go.
Thanks for the talk anyway, Phil. It was very interesting.
Okay, good. Any other questions at all? Okay, well, melt some solder. It's a great time to do it. You can get almost anything. So, okay, thanks very much indeed. Thanks for joining up and a meeting, whatever. We'll have a cup of coffee here, but so it'll be a meeting in 2 weeks' time, and we'll make announcements about that in due course. Thanks very much.